Go live. So we are live now. Every one of you, we are live. We are live now. Okay. Is it right? Yes. Yes. Okay. So it's 06, 07, 05, 04, 03, 02, 01, 00. Cut it. Next thing, this cut it. Cut it. Okay, ray optics is started. So please text me in the chat box from where we left in the previous class. Okay, so you're telling that it's a question of image and object height related. Okay, so that was in the spherical mirror, that is concave mirror. Hai na? Great. So recall question. Recall question. Okay, so I'll revise few of the contents thing. We'll take a recall question and then we'll solve this thing. Okay, so there was a recall question based on as you are texting, as per your text in the chat box, that is question of image and object height related. In case of mirrors which are spherical. ठीक है? समझ में आ गया? Okay. After this, we'll see this the topic which we have left in the previous class. We'll see here. Just wait for a second, student. Let me switch the pen tab and the mobile phone charger. Let me switch the pen tab and the mobile phone charger. Dun, 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 dun. So I'm switching it. Just hold on. Okay. Cool. So now I switched it. Everything is fine now. Okay. After the recall question and the combination of mirrors, after both of this, that is recall question and the combination of mirrors, we'll see refraction theory. Okay. After this, we'll be seeing a refraction theory. Also, we'll solve the numerical. So this is basically our today's goal. What is this? This is basically our today's goal. Okay. This we have to complete in any condition before leaving the class, that is at 5 p.m. So before 5 p.m. we have to complete this all goals. These are 3 goals of our today's class. Okay. Okay, let me start record to the cloud. So I'm going to the cloud also. Just hold on. Okay, students. So after this, if we are left with more time, okay, see. After this, if we're having more time, if we're left with some more time, we'll see this thing, that is apparent depth and normal shift. What is this thing known as apparent depth and normal shift? Okay? Apparent depth or normal shift क्या होता है, किसे कहते हैं? We'll see this thing. After this, we'll see refraction of glass slab or refraction through glass slab. After this, we'll see lateral shift. Lateral shift किसे कहते हैं? We'll see that. Okay. But before that, what are the 3 things I've told you? Revision and contents. Let us start and not waste the time. Yes. Yeah, this is a recall question for all of you. Just try to solve this question. Any one of you can answer. Okay, I'll solve this question for you. Okay, let us solve together this question. You and me. Okay, all the students. So we are having here radius of curvature given as 20 centimeters. Take. Since this is a mirror which is concave mirror, radius of curvature is 20 centimeters. ठीक है? तो ये concave mirror है, तो radius of curvature will be basically negative sign. Focus will be negative sign. We'll write here focus is equals to R by 2. That is 20 by 2, 10 centimeter. But since it's a concave mirror, I will write focus is, see, if anybody is facing any doubt in between, please, you can text at any time in the chat box. focus here will be what? Minus 10 centimeter. Okay. You can see from this key object distance is here given as what? This is what? Pole. So object distance here is given as u, that is equals to 5 centimeters. Okay. U is given to you 5, but with sign in conventions, if I'll take, this is equals to minus 5 centimeters. Okay. Now what they're asking us from the question, in the question wo pooch kya rahe hain, they're asking find out the position and the type of image formed. Two options we are having, either the type of image will be V, that is virtual, or either it will be R, that is real. Okay. But now we have to see whether the image will be virtual or real by finding the ultimate value of V, that is the image distance. Is it fine? Did you understood it? Yes or no? Text me here, yes or no. Good. Okay. Now let us apply the formula. 1 by V. Okay. Yes. Okay. So that's good. You can text in the chat box. 1 by U plus 1 by V equals to 1 by F. This is the formula for both of the mirrors among the types of mirror, that is spherical, concave or convex. Now U you are having is equals to minus 5 centimeters. Okay. And focus you are having as minus 10 centimeters. U you are having as minus 5 centimeters. Focus you are having minus 10 centimeters. Apply this formula now. Okay, Sonali, your answer is perfect. That's very good. Okay. So that's the right answer. So 1 by U, sorry, 1 by V, U kitna hai? Minus 5. You'll put this value minus 5 here. Then you will put this value, focus ka kya value hai? Minus 10. When you will solve this for V, kya answer aayega? The answer will be this 1 by 5 minus 1 by 10. So now take common this thing, that is 1 by 5. 1 minus half. So ultimately you will get this value, that is 1 by 10. Got it, students? So from this we can conclude V is basically 10. 10 ka matlab positive 10 centimeters. V is positive 10 centimeters. Yes, Sneha, that's right. Okay, good. If you're understanding the things. Plus ka matlab kya hota hai? If I take a concave mirror as in this recall question, and if this is pole here, students, this is origin. Okay. Object is at centimeters, which how much centimeter? It is at 5 centimeters. Object U distance. And the image is forming at plus 10 centimeters. What do you mean by plus 10 centimeters? Plus 10 centimeters. We'll say image will be on the virtual side, that is elusive side. Okay. It's not a real thing. So this will be the image, and this image, students, is what kind of image? It is virtual image because it's plus in the mirror world, in the polished side behind the mirror, you can call in the physics sense. Okay. Very good. Sonali, it's virtual image. See, what about other students? What about this Ankit, Monali, Anshta, Shruti, and all the students? Okay. I hope all of the students are able to understand the things, whatever has been written on the slides. Okay. Got it. Same answer. Very good. So iska matlab kya hai? The image is virtual image. Very good. Shushri and all. Now let us move towards this. So some of the students are texting me, sir, we were on this concept, which is known by the name, famous name. Not, it's not famous, by the way. Okay. It's just for fun. It's transverse magnification. Transverse magnification. See, students, isme karna kya in this topic? Don't stick with the derivation here. Okay. Let me on the video. See, in this topic, don't get sticked with this derivation. The ultimate thing, the useful thing which is required for us, you and me, for solving the numerical is this theoretical thing. Oh, sorry, this numerical, which is on your, this numerical formula, which is on your screens. What it says like this. If you are given one of the types of the spherical mirror, Either it is a concave mirror as it is given here, or either it is a convex mirror. Okay, if this is pole here, this is pole. This is suppose a point here which is at a distance u from the pole. Okay, see distance u. Why I just took here distance u? Because it's an object. Okay, so object is here at a distance u, and it is having the height as AB here. Okay, so we'll take that AB height is equivalent to height of the object. Okay, and this is A dash B dash height. This is height of the image. Okay, now what do we need to do? So if someone is asking from you that you are given an object of a particular height, say 4 centimeters on the principal axis positive, okay, or they say object is on the principal axis but negative, say minus 4 centimeters, whatever, you can take any integer value. And then they say that you are given the position of the object, position of the image also you are having, position of the object you are having. You have to find the height of the image in magnitude, also sign, whether it will be inverted or whether it will be upright, like straight. Okay, so for all these things you will use this formula which is on your screens. I'm highlighting this formula with your which color you want. Okay, let us take dark light green. So I've highlighted this formula in front of you. Okay, I've highlighted this formula. This formula, students, I've highlighted. You can see on your screens. Got it? So now we'll be using this formula in an application manner. Remember, now I'll be using this formula in an application of this question. Okay, so this is a question. Now I'll solve this question. Just focus carefully how I am solving this question by using all the things. That is the corrective formula for image distance, object distance, and focus. That is 1 by v plus 1 by u equals to 1 by f. And the previous slide which we have seen. Got it? See this carefully that. Okay, let me take the pen. Just hold on. Do you want to take a try on this? Do you want to try this question? Okay, so this question is already done. Okay. Okay, so this question is done. So we'll leave this question now. Okay. Yes. So let me leave this question. Okay, what about this? Velocity of image and the given figure. These types of question has been completed or not? Can anyone of you reply? Okay, so that's really great. Okay, I mean, one of the students have replied me कि sir ये तो complete हो चुका है. Sonali, you have replied. That's great. Sneha, you also. I mean, you must reply these things. So I'm asking from you: is this kind of question? This is among the types of question from concave mirror. This is also done. Very good. What about the next? This is this question completed? Okay. This is also done. Monali says done. Shushri says, Sneha says this is homework. Okay, yeah. I given this question as a homework. Okay, so we'll take this question as a. I'll give you the solution of this question. Okay. Sonali says yes, homework. Okay. So students, be focused very carefully on this PPT slide. I'll be solving this question, which is your homework question. I'll give you the solution now. Match with your answers. Okay. Very good. Excellent. All the students were texting. So now I'll be solving this question. Just be focused. I'll solve this in a very good manner. But by the way, before this, because since it was a homework question, text me your answers. Since it was a homework question, text me your answers, students. जिसने भी किया है, if you have solved it, please text the answer. Otherwise, I will solve, no issues. It's an online class. You are not pressurized, okay? Yeah, Sneha Ghosh, I think that your answer is perfect. Same for the Sonali also. I think maybe your answer, some of your answer may like, okay, let us check, okay? So students, I'll be solving this and then you will cross check the answer after I'll end the full solution. Okay. So let us take your favorite color. I don't know what is the favorite, but let me guess, white, black and white combination. Okay. See, you are given here that object is this. This is the object O. Okay. And this object is having the coordinates -40 and 1. Object coordinates. Objects का coordinates क्या है? -40 and 1. See this thing that -40 and 1, if we write it in the mathematical coordinate system, yes, this will be equals to, I can compare this equivalent to xy. So x can be written as -40, y can be written as 1. We can write this thing combinedly as x is object distance u equals to -40. Y is basically the height of the object. Y is nothing but the height of the object. That is +1 centimeters. Okay. And they are asking you in the question to find the position of image. Find the position of the image. Okay. See students, for the notes, I will give you the PDF format of this PPT slides. You can check from there. Okay. Now just proceed here. So find the position of the image ka matlab they're asking from you to find the coordinates of the image. If image is there, find the coordinates xy of that. Okay? How you will approach? So listen one thing. I have explained you everything, the information required for the solution of this question. But now this question can be modified after all this information which is on your screens. This question can be now modified in this way and can be asked by the questionnaire like this, that suppose you are given a concave mirror like this, concave mirror like this. Okay. And the principal axis is passing like this from the pole, and the pole is on the origin 0, 0. Okay. And the object is at a distance from the pole at 40 centimeters. And this object is also having the height equals to this. Height of the object is 1 centimeter. This is the height of the object. Okay. And now they'll ask you to specify all the position and the height of the images. So this question can be modified in this manner. So if I have like what you can say like this, then an interpretation of this question, okay, in some different manner. So modify and can be asked like this. Now I'll solve this question very easily. So you're given here that object distance u is equals to -40. 1 by v plus 1 by u equals to 1 by f. Okay. So 1 by v if we'll find, this will be equals to what? U equals to -40 centimeters. Okay. U equals to -40 centimeters. So we'll write here like this, -1 by 40 centimeters. F kitna aega? F will be, see, radius of curvature here is given as what? It is given as R equals to 10 centimeter. Focus value is R by 2, that is 5 centimeters. Okay. Since this is in concave mirror, I will say center of curvature will be where? It will be at this side, C. That is what? If you start from the pole, it is the negative side. And also if you see the Cartesian coordinate system, this is origin, this will be plus x, this will be minus x. Okay. So I will write here that focus will be equals to -5. -5. 1 by v, 1 by 40, minus 1 by 5. If we'll solve this thing, 1 by 5 will be equals to what? 1 by 8 minus 1. Okay. So this will give you the answer as See this. 1 by 8 minus 1 is how much? So solve it. Minus 7 by 8, 1 by 5. So from this you will get like this. V is equals to minus 40 by 7 centimeters. See, what is this V, students? This is, sir, the image distance. This is the image distance. Okay. Now we need to find the height of the image. So we get one thing here. Image distance is V equals to minus 40 by 7. Height of the image we need. How you'll find? We need to formalize this. We need to formalize this height of the image upon height of the object. Height of the image upon height of the object is how much? Minus V by U. So we'll write here. Okay, just hold on. So object height was how much? Object height is 1 centimeter. You can see. Plus 1 centimeter. Minus V by U. V is how much? V you got here as minus 40 by 7 centimeter. U is how much? U here is, you can see it's 40 centimeter. Okay, but since we are taking the sign and conventions, I will write here what? See, if we are taking the sign and conventions, you will write U as minus 40. Okay. U you will write here as minus 40. Minus 40. So through this, you can conclude like this. Height of the image will be 40 by 7 minus 40. So this will be minus 1 by 7. Okay. So from this, I can conclude like this. Height of the image will be what? Minus 1 by 7 centimeters. So from this, we get the coordinates of the image as this. Coordinates. Coordinates of the image are what? V is equals to minus 40 by 7. And height of the image is minus 1 by 7. So see, if we convert this coordinates, that is the image distance and the height of the image into X and Y. So what you will write here? Any one of you students? What you will write here, students, if we convert this into coordinates? X, Y. Yes, this is right. This is minus 40 by 7 and minus 1 by 7. Okay, so XY is resembling to this thing, that is V and height of the image. V is minus 40 by 7. Height of the image is minus 1 by 7. This is the right answer. So how many students got this answer as right? I mean, you can text in the chat box. Okay. Okay, now we'll not waste the time. We'll go with this topic, that is combination of mirrors. Okay. See, I'll be solving only one question. Rest of the question, that is the second part, I'll give you as a homework. Okay, because we also have to see today this topic, that is refraction. Got it? Yes. Okay, so now please be focused on the PPTs. Now I'll be teaching you this, like I'll be explaining you this topic, and see how to approach these kind of questions where you're given 2 or more mirrors. Say it will be a combination of mirrors. Okay, let me take white pen. Which pen you want? Yellow, red, green, yellow. Which pen? Okay, white, yellow. So see, either you'll be given a concave mirror or you'll be given a convex mirror, or you'll be given a plane mirror, or you'll be given what? Combination of these mirrors. Okay, so either you can take 2 concave mirror, 3, 4, whatever you want. Okay, so it's like playing with all these mirrors. Okay, you can mix them and make a very complex kind of, you know, a mirror situation, and the object you can place in between anywhere on this principal axis, and then it will be asked from you, take the number of reflections, say 1, 2, 3, starting from a particular mirror, and find the final image. Got it? So this, you can see the question. Let us let us draw this question on the next slide. So here I'm drawing this. This is what mirror? Concave mirror. Concave, 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 concave. Now this is principal axis. This is Mr. Plane mirror. Okay. So I've drawn this plane mirror here. And now the object is on the screen. O for object. ROC means what? Radius of curvature. It is 20 centimeters. Next thing, object is at 15 centimeters. Okay. And this is named as mirror 1. So of course, it's one of the, there are two mirrors in front of you. अगर एक को it's named M1, the next will be what? M2. Okay. Next mirror I'll be writing here as M2. Let me close this thing. M2 mirror. See, now what the question has been asked from you students is this. Key object is placed at 15 centimeters from the pole of a mirror which is concave. Okay. Taking first reflection from M1 mirror. Taking first reflection from M1 mirror. Find the image. Okay. Then using that image as an object for the second mirror. Find the next image. Then again using that image as an object for the concave mirror, which is the first M1. Find the final image. So if we switch back to the question slide, you can see this here, that find the position of the final image after the three successive reflections, taking first reflection on M1. Got it? So we are having three lifelines here. Okay. So let me mark here with which color you want. Blue, dark, no, light. This. So you have to start with the concave mirror, then with the plane mirror, then again switch back to concave mirror, CPC. Okay. So let us start it. See, now the question, first part is this, that is this lifeline. So I'm putting a tick, I'm going to put a tick on this. Okay. Tick this lifeline. So see, object is at distance equals to U equals to minus 15 centimeters. You know why I took this minus? Because we're going against the rays of this object. So now use the mirror formula. 1 by V plus 1 by U equals to 1 by F. Since it's in concave mirror, we say what? Concave mirror ka focus, what is this? Negative or positive? Any one of you? Sir, we don't know. So it's like this. R by 2. R ka matlab kya hai? 20 centimeter. Okay. It's concave mirror. Yes. So one of the students have texted, what is it? Minus. Very good. Okay. Excellent. So we'll say here R is negative. So its focus is given by R by 2. So F will be also negative, minus 20 by 2, that is minus 10 centimeters. Put this value here. Put the object distance here. Find the V. You'll get the answer. So 1 by V plus 1 by U equals to 1 by F. 1 by V minus U is what? 15. Focus kitna hai? We have already seen. Minus 1 by 10. Anybody found it the answer? Anybody got the answer? If you solve this thing, 1 by 15 minus 1 by 10, LCM 30. This is what? 2. This is what? 3 minus 1 by 30. Finally, you got the answer is V as minus 30 centimeters. Minus 30 centimeters ka matlab kya? Matlab against the object rays. Okay. If I see, this will give the first image. So we have used our first lifeline. Okay. I1 is completed. I have already put a tick there. Okay. You can see this green sign. So if I draw the image with the yellow, and which color you want? Okay, let us take this color, purple kind of. So first image will be at 30. Okay, so I'll mark this here. Suppose it is 30. Okay, assume. See, since the figure is like this, you can say like 15. So how you can put here 30? But assume it. Okay. Suppose we can increase the size of the principal axis, the length of the principal axis. So due to which, I mean, through that you can think. So here you can see this. Where's the image is? It is at 30 centimeters here. Take negative. It is in this direction from the pole. We know this direction is negative, and that direction, virtual direction, is positive as per sign and conventions. Take. Now also, if you see the question, switch back on the slide, you can see here that the distance between this mirror and the plane mirror is 40 centimeters. Okay. If the distance between this concave, and this plane mirror is 40 centimeter, and the image is lying here on this position on the principal axis, we'll say what? That what is this gap? I mean, what's the magnitude distance of this gap? Okay, you can see this. It's 40 minus 30 centimeter, that is equals to 10 centimeters. Okay, this is 10 centimeter of the gap. So we'll get the image. So this is the first image, I1. Now the question is like this. That is, this is what kind of thing? This is a plane mirror. and you are having a I1 image here at 10 centimeters. Okay. So this image, which is formed from the concave mirror, will act as a kind of an object for this plane mirror. Then you will get a second image, and we know the concept of how the image is. Students, I know that you know this concept, hai na? Object ka, if the object is placed in front of the plane mirror perpendicularly, how you draw the image? Just take the perpendicular concept. Okay. So now I have to use that thing here, and you'll get this thing, that is image I2 will be at 10 centimeter here. This is I2 image. Okay. So again, we have used our second lifeline. I'm going to tick there. Tick, tick. Now we are just having the last lifeline remaining. So how to use it? Simple. So we got an I2 here at 10 centimeters. Okay, I2. And also it is given in the question, you can take only 3 lifelines, 3 reflections back to back. So now the question becomes like this. That is, we are having, okay, which color is remaining? This is fine. So now we are having an object, which is basically an I2 image. I2 is what? It's a virtual image. I2 kya hai? I2 is virtual image. Okay. And this virtual image of the plane mirror, or in the plane mirror, will be acting as a virtual object for concave mirror. Okay. So the distance of this virtual object will be what? 40 to itna tha, distance between the concave and the plane mirror. Remaining is 10. So this will be complete as this will be equals to 50 centimeter. Okay. So now we'll use this U, and the question becomes like this. So the last lifeline, third reflection, I can say. The third reflection. Okay. So someone got the answer, I think so. Okay. That's fine. It's minus 50. Okay. So this is a concave mirror. Principal axis. U object is at equals to minus 50 centimeter. Object. And now you need to find the image, where the image will be. V find karna hai, okay? And the radius of curvature is already given to you. What was that? It will not change because we haven't curved the mirror, okay? So ROC is 20, F will be minus 10. ROC is 20, F will be minus 10. Minus 10 centimeters. Put the values. 1 by V plus 1 by U equals to 1 by F. U kitna hai, students? U is minus 50 centimeter. Okay, focus kitna? Minus 10. Put the values. 1 by V minus 1 by 10. Focus minus 1 by 50 centimeters. Okay. So through this you will get V. V kya hota hai, students? V is the image distance. So if you'll find this, 1 by 10 minus 1 by 50, 1 by 10, 1 minus 1 by 5. This will give you what thing? This will give you 1 by 10, 4 by 5. 2 to the 4, 2 5 to 10. 25. So your answer is this. From this you get V is equals to 25 by 2. That is 12.5 centimeter positive. Is it negative or positive? It's positive. So you can conclude like this now. Hold on, it's negative, no? Yeah, it's minus 4 by 5. So from this you will get 12.5 as negative. Negative matlab on the same side of the object. Is it virtual or real? Sure, it's what? It's the real image, okay? So now we'll write here that its V is minus 12.5. 12.5 centimeters ka matlab kya hota? 12. Yes. Real image, good. So we'll say here, if this is the picture, the object will be somewhat here with minus, because if we go against if we start from the pole, if we go against the object rays, this will give you 12.5 this thing. Okay, V is here. So this is the I3 final image, and which is your answer. Got it? So final image is what? Final image is I3, that is 12.5. I1 kitna hai? I1 is this. I1 is how much? It was 30 centimeters. Minus. This is what? 10 centimeters. I3 is how much? I3 is minus 30 centimeters. Okay, I hope it's clear. Okay, we got the 3 reflections and the answer. Okay, now this is a question homework for you. It is same based on the topic which we have just studied recently, that is combination of mirrors. Combination of mirrors. Okay. So take the two mirrors. This, see, the thing is this, the difference in this topic is this question is this, that you are having, yes, you are having here concave mirror and one what? Convex mirror. So in the previous question, we were having this thing, that is concave mirror and plane mirror. Okay. So be careful. In this question, you will be using the common formula, that is 1 by V plus 1 by equals to 1 by F, by taking VUF in a proper sign and conventions. Okay. Fine. Convex के लिए remember it's positive, F is positive. Concave के लिए F is negative. Just these sign and conventions will change. Rest of the things are same as it is. Now students will see in the last 15 minutes refraction and a very good, interesting animation, funny animation. Okay. So I hope you all are ready. Yeah, this is also a question. I'll take this question as a recall in the next class. Fine. Yes. Okay. So now we'll start the refraction, a brand new topic. This is a very fresh topic and very interesting. Okay. Refraction for all of you here. See, before starting the theory and before like explaining anything about this topic, that is refraction, we'll see a very interesting animation, as I've told you in the beginning of the slides. Okay. So I'm going to launch it now. So all of you are ready? Yes or no? Yes or no? All of you are ready or not? Yes. So I'm launching it here. Okay. So sound is available now.
Why does a pencil look bent in water? Wow, that was a very cool magic trick. Now check this out.
यार ये बड़ा बड़ा लोचा है यार. यहाँ बंदे बैठ जाते हैं ना. अब इसमें कैमरा कभी बार बीच में ऑन करना.
Hey, stop crying. Your magic wand is not bent or broken. Look, it is safe. Do you know why your magic wand appeared bent in water?
सबसे बढ़िया मोबाइल से टेंशन ही नहीं. एकदम बेस्ट, हाँ बेस्ट क्वालिटी वीडियो आता है.
It is because of refraction of light. Refraction of light is the change in direction of light when it passes from one medium to another obliquely. So, what do you think are the two media here? You don't know? No worries. I will tell you. They are air and water.
Oh.
When the light rays coming from the tip of the magic wand pass from water to air, they change their direction. That is, they get refracted. When these refracted rays reach our eyes trace them backward as straight lines. Due to this, the rays appear to come from a point slightly above the original position. Hence, the magic wand appears to be bent in water.
Oh.
Similarly, like the magic wand, a pencil appears to be bent in water.
So students, some students may be feeling doubt in this. I launched this animation again, okay? I hope you liked it, isn't it? Isn't it, students? Did you like the animation? Okay, I'll launch it again. Okay, just watch carefully one more time. So I think we all are ready for this. So Sonali liked it, Sneha liked it. What about others? So all the students must participate. No. Shushri, Anshuta, AP. What about you? Everyone is important. You know, everyone is important. Okay, so I'm launching this again.
Topic: refraction of light.
Huh?
Why does a pencil look bent in water? Wow, that was a very cool magic trick. Now check this out.
Oh.
Hey, stop crying. Your magic wand is not bent or broken. Look, it is safe. But do you know why your magic wand appeared bent in water?
Huh?
Oh.
It is because of refraction of light. Refraction of light is the change in direction of light when it passes from one medium to another obliquely. So, what do you think are the two media here? You don't know? No worries. I will tell you. They are air and water.
Oh.
When the light rays coming from the tip of the magic wand pass from water to air, they change their direction, that is, they get refracted. When these refracted rays reach our eyes trace them backward as straight lines. Due to this, the rays appear to come from a point slightly above the original position. Hence, the magic wand appears to be bent in water.
Oh.
Similarly, like the magic wand, a pencil appears to be bent in water. Topic: refraction of light.
Okay, students, I hope you liked it, isn't it? Yes or no? Okay, I hope you liked this animation and you understood everything because we have seen 2 times. 2, victory. Victory it is, okay? So we have seen 2 times. Now, we'll see a little bit about the theory, okay? And one question, very easy question, easiest question of the universe. After that, we'll end the class. Okay? Happy? Okay. So now, take this black pen. See deviation or bending of light rays from there. Okay. So is my voice coming low now? I mean, it was from the beginning or now? Is my voice fine? Sneha, Sonali, whatever. Is my voice is fine? Now is the voice fine? Now is the voice fine? Like this. Okay, this point I'll explain on this. Okay, on this question kind of thing. Okay, let us conclude here only. Suppose on this. Suppose you're having a boundary. Suppose you're having a boundary like this, which is separating 2 surfaces. Okay, this is what? This is suppose air or vacuum. This is suppose water. And the normal is like this. And the normal is like this. You can see on your screens. Okay. And suppose light rays goes from a denser medium theta W towards a rarer medium. So whenever the light ray goes from a denser medium to a rarer medium like this, it will bend away from the normal. So this is theta in air or vacuum. You'll say like this, theta A or V will be greater than theta W. Okay. Next point is this. Suppose you're having a boundary like this, air or vacuum. And if the line is perpendicular to it, And if the light ray enters like this, theta W. So okay, let us now take a different case. Okay. If the light ray enters in another direction from a rarer medium, theta of air. Now, if it enters into the denser medium, it will bend towards the normal. So now theta W will be less than theta A. Okay, it happens. This is water. And remember this is due to a property known as refractive index. Okay. One more point is this. Let me tell you this thing before ending the class. Okay, suppose we know this thing, light in the air is having the speed c, speed of light. But when you project this light with some source, okay, with a speed of light that is c here, okay, so the magnitude will be like this. That is, speed of the light in the medium will be like this, c by mu or c by eta, where mu and eta is what? Refractive index. Where mu and eta will be what? It will be refractive index. Okay. So we'll say here more refract. See, you can see this. The speed of light, which was having the common speed c in the air or vacuum as it is, it changes when it is projected from the water medium. Okay. So by with this, where eta is the refractive index of the medium. So for water, n value is 1.33. I will explain everything in the next class, but just for now, an overview. For glass, it is 1.5. So more refractive index means less speed of light. You can see, since speed of light is like speed is inversely proportional to refractive index. Refractive index property, optical property of the medium is more, speed will be less. Speed will be more, refractive index will be less. Okay? These are some fast, this is just a fast explanation of this thing. Now, students, this question we'll see in the next class. So remember, we have just paused on reflection of light. I will explain you again in depth, starting from this theory after an animation in the next class. Okay? Till then, bye-bye. Tata, tata. Be happy. Okay? So be happy. This is end of our day. Enjoy your life, enjoy your days. Okay, bye bye. So this was all about today's class. If you're facing any doubt in this, I mean in today's class, please text in the chat box. If you're facing any doubt in today's class, please text in the chat box. Any one of you. Okay. So Tata sir, Sneha sir, Tata, bye everyone. Anshuta, Sonali, Akshita, and Abhay and Akshir. All the students. Okay. Bye P. Bye everyone. Got it? Got it? Okay. I'm ending the class. Time is up.